Hello students, let us continue the chapter cubes and cube root. Exercise 7.1, that is question 2. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. So we have to find out the smallest number by which the following numbers should be multiplied to obtain a perfect cube. So we'll start the problem. First we have to factorize this one by using prime factorization method. So first number is given here is 243. We start the prime factorization. So first we take 3 into 81 will be 3. Next again 3 will take 3 into 27 will be 81. Again we'll take 3 into 9 is 27. Next is 3 3s are 9. Next again 3 1s are 3. So this is, multiply all this. So 3 into that is 243 equal to, that is 3 into 3 into, there are 6 3's. So next step, there is, so by, next step by, before this we have to write by prime factorization, that is 243 equal to, that is 3 into 3, 5 3's are there, just write down this. Next step is the prime factor. So if we group, there is only one group and 1 3 is missing. So prime factor 3 does not appear in a group of 3. So what happens? See here we have 3 plus 2. So 3, this is one group and 1 is left out here. So for this, what we should include, that is again write down 243 is equal to, write all the 3's, that is we have 5 3's here into 3. Again one more 3 we have to include. So multiply all this, we get back, that is, which is equal to 729. That is 243 into 3, that is 3 3s are 9, 3 4s are 12, that is 3 2s are 6, 1 7. So which is a perfect cube. Hence the smallest number by which 243 should be multiplied to make a perfect cube is how much? 3 is the answer. See here, one more 3 we included. Multiply this, there are 2 pair of, that is 3 cubes. So we multiply, we get 729. This is the answer. So to make this number a perfect cube, we have to multiply it by 3 and one more 3 is added. So this is the first problem. We move on to the second one. The second one given as a 3-digit number 256. So first step is prime factorize this number, that is 256, 2, 128 again 2, how much, that is 64, again 2, 32, again we take 2, then this is 16, again 2, this is 8, again 2, 4, 2 2s are 2 1s are. So next step, what we have to do to make, how many are there? 1. So there are how much? There are 3 pairs of, that is 2 cubes. So we write, to make it a perfect cube, to make it perfect cube. So there one more 2 is left out here. So much, that is 8 2 is there. Therefore we need, so here we need, that is 1 2 so what happened, that is 256 into 2 is equal to 2 into 2 into 2 into 2 into 2 into 2. Again, how much here? 3 3 6 6 3 9 we have to get. 2 into 2. See, this is one group. This is here. What is the meaning? Means 256 should be this one, just one. This one 256 should be multiplied by 2. So 1 2 is required. That's all. So add 1 2, then this will become, that is 2 cube into 2 cube into 2. That is 3 groups of 2 cubes. So this is by just next line, by laws of exponents. As we studied in the previous chapter, we know the laws of exponent means this is all, take 2 into 2 into 2 and the powers are common. Just write down the common thing once. So this is by laws of exponent. So this can be written as 8 cube, which is equal to 512. So next, by prime factorization, this before only we have to write. So I am writing now what we got, that is prime factorization, multiply all these 2 into 2 into how many 2's are there, just write. After this step, then we have to continue this. So 256 is equal to, that is 2 into 2, same thing, that is 8 times 2, 6 7 8. Okay, next grouping the factors in triplets. Triplets means that is the cube root. In the above factorization, what we write, 2 remains after grouping, means these three and there is 2, one more is required. 2 remains after grouping. So what we have to write, that is 2n after grouping 2's in triplets. So meaning is 2 groups we made, one more 2 is required for the third group. Therefore finally, so 256 is not a perfect cube. Perfect cube. So therefore after this write down these steps and then we write this. So first write down this step, then continue with this last. Finally we have to write. So after this I'll write here. So which is a perfect, which is a 2, that is 5 1 2 is a perfect cube. Hence what we have to write? Hence the smallest number by which 256 must be multiplied to obtain a perfect cube is 2. Once again I'll explain. The given problem was 256. We first prime factorize this number. We got 8 2's here. Then we move on to here. This step by prime factorization, write down all this. 256 equal to this one. Group this into triplets, means 3 numbers into one group. One is missing. So just write down these steps. After this what is required. So this is not a perfect cube. After this we continue to make it a perfect cube. What we have to do? We should multiply 256 into 2. So we got, that is 3 groups of triplets here. See here. By the laws of exponents we can write as, take all these things, multiply, then the cube will be common. Then 8 cube is equal to 5 1 2. This is a perfect cube. So finally last statement we have to write is, this 5 1 2 is a perfect cube, as the smallest number by which 256 should be multiplied to obtain a perfect cube is, that is 256 should be multiplied into 2. This is the solution for the second problem. We move on to the third one. Third one given here is 72. So 72, we see first step, same prime factorization. 72, we'll take 2, 36 times, then 2, 18, then 2, 9, then this one takes, next comes 3 and 1. So next step we write how much we have got, that is 3 2 we have and 2 3 we have. By prime factorization, 72 is equal to 2 into 2 into 2 into 3 into 3. Grouping the factors, next step, grouping the factors in triplets. Grouping the factors in triplets, the prime factors 3 does not appear in group 3, means 1 3 is missing, group of 3. So therefore we can write as 72 is not a perfect cube. So what we have to do to make, next step, to make it a cube, we need one more, that is one more 3. So one more 3. So in that case what we have to do is take 72 into 3, which is equal to, again write down the triplets 2 and just add 3 to this one. So we got through 2 set of triplets, that is 2 cube into 3 cube. By what? By loss of exponents. We can write, take this number 2 here, this is common here, 3 here common, cube is common, write down. Again we can write this as, say, by loss of exponent 2 into 3 cube is common, write 1 cube, which becomes 6 cube, which is a perfect square. Multiply this, how much we get? 3 2s are 6, 3 7s are 21, 216 we'll get. So write down which is a perfect cube. So perfect cube. Hence what we write? One more statement is left out. Hence the smallest number by which 72 must be multiplied to obtain a perfect cube is 3. So this is the solution. Once again I'll explain. Take 72, factorize it, that is 2 36, again 2 18s are, again this one is 2 9s are, then take 3 3s are 9, then 3 3s are 1. Next, by write down a statement, that is by prime factorization. So write down 72 the number, then all this 2 2 2, multiply all this 2 into 2 into 2, 3. We have 5 numbers, of which 2 appears 3 times and 3 appears 2 times. Okay, now grouping the factors in triplets. So in order to, we are calculating for cube root, it should be triplet. Triplet means 3 numbers. So this one should be 3. So now when we multiply this, we get only one pair of triplets, that is 2 into 2 into 2. And 3 into 3 is only 2 is there. So next step is, the prime factor 3 does not appear in the group of triplets. So here this one is triplet, this one is not a triplet. So what to do to make this one a triplet? So here therefore we take 72 is, so we say first we will tell this 72 is not a perfect cube. To make a perfect cube, what we have to do? To make it a perfect cube, we need one more 3 is required here. See, one more, if we multiply it by one more 3, it will become 72 will become a perfect cube. So in this case what we do, 72 we multiply into 3. So which is equal to 2 into 2 into 2. So this is 3 times anywhere we got. Again multiply this one by 3. So next step is, how much we got? 2 triplets we got, that is 2 cube into 3 cube, which is by loss of exponents. Means this is 2 here, all are common, write 2, then 3 all are common, 3 write, and cube in each case. Again by loss of exponent we can write as this 2 into 3 cube is common, write outside. So next this one becomes 216 when multiplied by 3 this side. Then next this will become 2 into 3 6 cube, which is a perfect cube. So 6 cube is equal to 216. Hence this, so this one 6 into 6 36, 36 into 6 6 6 are 36, 3 6 3s are 18, that is 19 20 21. Okay, this is 3 cube is 261. As the smallest number by which 72 must be multiplied to obtain a perfect cube is 3. So you got the solution. So in order to make it a perfect cube, we should multiply the number by 3. So this is the solution for the first 3 problems. So we'll continue the next problem in the next class. If you have any doubts, comment me, like all the videos, share the videos, subscribe my channel. Thank you.